So Geraint, exciting news. We've got a new book coming out.
Excellent. And what's it called?
Oh, what is it called? It's called The Cosmic Revolutionary's Handbook, or How to Beat the Big Bang.
Okay.
So, very exciting. Well, what's the motivation there? So actually you sort of pitched this book to me and then we wrote it together. So
Okay.
What got us started?
So what got us started, I guess, was that we both give lots of public talks and we talk about astronomy, astrophysics, and a lot about cosmology and the evolution of the universe. And at the end of the talks, then, there's a question and answer session. And normally you get some really good questions and answers. Lots from the younger kids have very deep questions. But often in the audience, there is one or two older, often gentlemen, often retired engineers that essentially don't like modern cosmology, right? There's aspects of modern cosmology that they just don't like. And so they often have their own ideas and they say things that like, how would the universe behave if it was like this or like that or like the other? And they have their own ideas and theories and they want to know essentially why astronomers don't take these kind of ideas seriously. And so I think you and I have answered the same kinds of questions on this over and over again. Not only in talks, right? There are other ways that we get to interact with the broader public.
Yeah, so they often send us emails. So I actually got one about 3 weeks ago. It was just, hi, I live in the area. I was wondering if I could come and buy you a coffee and present my theory of the universe to you. Yep, older gentleman, biochemist, I think.
Oh yes, they often have scientific or engineering training. Yes.
Yeah. And so I thought, well, look, I'll be here. I just sent him an email. I'll be here eating my lunch, and if you want to come and sidle up and bring me a coffee, and we'll have a chat. Then so we did. We just get these emails all the time. I remember getting one quite early in my PhD. Actually, it was a guy. He had this theory. He had a YouTube video about his theory about actually the whole universe was rotating, and so redshift is kind of like the outer bits are going faster than the inner bits, or something like that.
Yeah.
One of my favorite ones was actually while I was here as an honors student, and we were I was in the office with the other honors students, and a colleague of ours, Barry and James, got an email from someone with one of these theories, and this guy, I assume it was a guy, I don't actually know, but that's a fairly safe bet, said, I've got this new model for the universe, and then he scrolled down through the email, and it was literally a model built out of clay and pipe cleaners, and bits were sticking into other bits, was his theory for the cosmic microwave background. So we get these all the time. I was comparing notes with a mate of mine who I know who's Australian, but he lives in England, but he's an archaeologist, and he gets these as well. and aliens is a common theme between us. So what sort of answers? I find you end up giving the same sort of generic answer, but what do you end up telling these people?
Well, I think this is what forms the basis, the crux of the book, right? Is that you might have a picture in your head of how you think the universe works, but you need more. And this is what the book outlines, right? Is what is the scientific process? What has led astronomers and cosmologists to come to this picture we have of this expanded universe that started in the Big Bang, something that's developed over 100 years. And it's not just about the pictures. What there is, of course, is you have your observations and you have your theory, and you need to compare the two. Yeah. And the scientific theory that wins, of course, is the scientific theory that can best describe the observations. Not just cherry pick the observations, not just pick your favorite observations, but has to be able to explain all the observations. So, in the book, of course, we start from the very basic premises, the very simplest ideas of the universe, some of the famous paradoxes, Olbers paradox and all this kind of stuff. And we work our way through the key observations. Yeah. And we talk about how modern cosmology interprets those observations. But I think also importantly, we point out how those observations basically slay some competing ideas. Yeah. And there's a few cool examples.
So, Olbers paradox I find to be a really important one. Now, a lot of people talked about this, we won't go into too much detail. But basically, you might think, for example, that the universe has just been always there.
Oh,
and
but you should probably start by stating what Olbers paradox is.
Well, let me set it up like this way.
Yeah.
So, suppose you thought there's just stars all over the place. You look out the night sky and there's stars. Maybe you think it's just stars forever, and the universe has just always been there and it's just always sat there. And that might be a way you think the universe is. But when you think through that for a second, especially when you understand how light travels and how we see light and all those sorts of things, the paradox comes from the fact that actually, if that's the way the universe was, any direction you looked in the night sky, follow that line of sight, you would eventually land on a star. If they're everywhere and you can see forever and they've all just sat there, eventually your line of sight hits a star. And so that bit of the night sky should be as bright as a star. Now, the fact that it's further away doesn't actually matter. That's an interesting little bit. The fact that it's further away just means it looks a bit smaller, but that smaller thing is still looks as bright, surface brightness, as a star. And so now you think, okay, one of those assumptions we made has to go. And we sort of discuss different ways you could do that in the book. But that's the interesting thing. You have this picture of the universe and it all sort of, you think it's all working out. But once you start getting into the details and think about if that was true, what would the sky look like? What would the universe around me look like? You find some interesting failures from ideas that we thought were pretty obvious.
Yes. So as we noted, we work our way through the key observations that have led us to this idea that we have this expanding, accelerating universe. That's not to say that we understand everything about the universe, of course, right? We stress that there are still things we need to solve. We don't know what dark matter is. And in fact, there's a conference on here at the University of Sydney this week where astroparticle physicists are here. Lots of ideas about what dark matter could be, lots of experiments we could do to try and find it. But I was at a talk last night where a famous astronomer, Joe Silk, basically said he started thinking about dark matter back in 1984. And we know as much now as we did then at some level, right? About what it actually is. And of course, then there's the question of dark energy, which is the thing accelerating the expansion. And we know even less about that than we do about dark matter. And what we point out is that there are still mysteries to be solved. But I think it's important to realize that this model, it's called the lambda CDM model, the dark energy plus cold dark matter model of the universe that we have, actually does the best in explaining all of the observations. No matter how much certain people rant on YouTube videos or back in the the corners of the internet where they point out that as cosmologists and astrophysicists are basically mad and demented and essentially misinterpreting the evidence, this one model of cosmology does do the best job as it stands.
The way we lay out the book is here's how you buy your ticket into this game. So here's the there's a competition between cosmological models, and if you want to start telling us about dark energy and dark matter and how your model's going to solve it, okay, that's the game you want to play. There's a ticket you've got to buy. There's some basic stuff before then, like Olbers paradox. You better not have a blazing bright night sky, and you better be able to explain redshift, and you better be able to explain why there is a certain abundance of elements there are in the universe. So there's a set of basic things that the Big Bang Theory earned its sort of living. It got to where it is by explaining those, and it's not perfect. Okay, so if you can come along, explain that stuff, buy your ticket, then you're in the game. Then you can start saying, well, I've got a better explanation of all the things where the Big Bang Theory kind of fails.
That's right.
Or at least struggles.
Yes.
So, when's this out?
Early next year, I think March 2020 is when we expect it to appear.
Sounds about right.
Yeah, it's available on Amazon to pre-order.
Yep, and there'll be an audiobook coming as well. And the wonderful thing is we didn't have to do it this time. That's really, really wonderful.
Yes.
All right, so keep an eye out. We'll all keep an eye out for that. I'm sure we'll have more to say about the evidence in the book as we go along.
Yes, and you'll put a link to Amazon.
Of course. Go click that right now.